Hello everyone, welcome to Programming Knowledge. Welcome to yet another tutorial on Programming Knowledge. So in today's tutorial, what we are going to cover about graph theory. So let's get started with the graph theory. So here you can see that I have a graph. So it has nodes and edges. So let's start with the representation of the graph implementation. One is adjacency list. We are going to do adjacency list, and another is adjacency matrix. We are going to implement both and see how we can implement them. So first, let's get started with the user input. First input would be v comma e, number of vertices and edges. Then for every edge we have u to v direction. Okay, so for every edge we have u to v direction, and in this case we also assume that is a so we are and let me just I'm also mentioning this. This is an undirected graph, so I'll comment this also. Undirected graph. Right now we are working with undirected graph, and we have two types of representation: agency list and matrix. And then for every v comma e, for every edge we have u comma v. So first, how many let us count how many edges I have, vertices I have. There's 1 2 3 4 5 6 and 7 vertices I have. And how many edges I have, let me count them also. 1 2 3 4 5 6 7 8 9. So I have 9 vertices. So let's go with the representation. I have a connection with a to b. So a to b I have a connection, then a to c, then a to f I have a connection. So uh, then for b, uh, now you can assume that since I have told you that it is an undirected graph, so the connection would be available from a to b, then b to a. So you can assume, because I have mentioned clearly I mentioned that since it is undirected graph, so from this you have to assume that if I have a connection from a to b, then I would have been a connection from b to a, since this is an undirected graph. Okay, and the next, let's get another. Then I have already an edge with a to c is covered. Then you can see c to e, C to F, and C to D, and then we have D to G and G to F. Okay, so let me count how much this should be equal to 9. 1 2 3 4 5 6 7 8. We are missing with one edge, so let me check which I'm missing with. I have C to A, yeah, I have C to A, C to F, C to E, C to D, then D to G is done, G to F is also done. I guess I am missing with this one, E to D. I'm missing with E to D, so you can cover this with E to D, or if you want to keep it lexicographically, so either you type this at D to E, or E to D is the same thing, because I have mentioned you that since this is an undirected graph, so you have to make sure, because it is mentioned here that it is mentioned that like if it's D to E and it is an undirected graph, so you have to make a connection for E to D. So E to D is equal to D to E, or E to D is same. Okay, so this works for everyone, like A to C is equal to C to A, because it is an undirected graph, I have clearly mentioned. So let's start with the representation now. So let's have a matrix. uh, what we can do first, we need to what we can do, I'll tell you one thing. You need to take v comma e is equal to map int comma input dot split. And now what we are going to do, so this is uh, then we need to, for I in range uh, edges, I'm going to have u comma v, u comma v. uh, this is let's we'll do str input dot split. And what are we going to do, from collections import default dict, and I'll declare graph as a default dictionary where the key is would be the vertex, that is going to be a character, and the value would be a list, agency list we are going to. So by default I mentioned this. So here I would do graph of u dot append v. We are going implementing agency list first, and graph of v dot append u. Why would I'm doing this? Because I've already told you this is an undirected graph, so the edge A to C is equal to edge C to A. So then what we are going to do, then let us do one thing. Let us print this. So for I in graph, so for V in graph, print V comma D graph of V. Yeah. So we are done with the first representation, I guess. So let us take the input. For the input I would remove this, and I would copy this. So let me run this. Yes, so on the left I would put the output, graph of v dot append u unhashable list. Yes, now this works perfectly fine. So that was an error due to map, because it was it was taking a data structure as a tuple, and since tuples are immutable, so immutable things are never hashable. So in Python, so this was throwing an error. Now you can see. Let's compare this representation with our graph. So now you can see, now with the representation with the graph, you can see what I have. Like I have an A, then like with A I have a connection with, I'll have a green color. Like with I'll have with A you have a this connection, with A you have a this connection, and this. So A C F, from B you have a this connection, B to A is fine. C, for C is D is there, yes. F is there, yes. E is there, yes. A is already there, good. Then for D, let's come to D. You have C, E, and G. Good. For G you have D and F. Yes, D and F, perfectly fine. For F you would be having G. Yes, G is there. C is also there, and A is also there. Okay, and for E you have C and D. So perfectly fine. For every vertex we have a uh, list. So this is a perfect representation of the graph in adjacency list. So you can how we are going to traverse this. For this we can have two types of traversal. One is depth first search and breadth first search. We are going to cover that. So thank you guys, thank you for watching. So we'll also cover the traversal in the next tutorial. So thank you guys, thank you so much.